Here's going through the brainstem. So the inferior colliculus, this big thing here, there's these two lumps here. Who knows what the inferior colliculus is? Auditory, yeah. So that's one of the sensory auditory filter pathways. This is the area that Hugh Lim is actually studying really intensely on how it's wired up to the auditory cortex and back down to the cochlea, and then how we can insert electrodes into there to stimulate, to replace auditory input for people who lack a cochlear nerve to stimulate, which is what we stimulate with cochlear implants. So here at the top is the thalamus, and then you have the mesencephalon, which is this part of the brain, which has the inferior and superior colliculus. The superior colliculus is involved in moving your eyes and keeping your eye movements coordinated with your body movements and things like that. And then the pons, which is that part of that huge nerve bundles that are coming from the cerebellum and then rejoining the spinal cord. And then the medulla oblongata, which has a lot of your nuclei coming from the cuneate and nucleus and the gracile nucleus, and then the nuclei going back down. So the sensory coming up and the ones going back down the spinal cord. So slicing through the brainstem, you can see areas like the substantia nigra, which stands for the black substance. And this is that area of the brain which has lots and lots of dopaminergic neurons. The dopaminergic neurons are the ones that die when you get Parkinson's disease. There's this famous movie called Awakenings. Who's seen Awakenings? So Awakenings is this great movie where this doctor actually was Oliver Sacks, I believe, and he was played by Robin Williams, and he discovered that these patients weren't just frozen and that they weren't just comatose, that if you actually made them do something by throwing a ball at them, they would actually react. They just couldn't produce any conscious movements. And he thought, well, look, maybe these guys are missing dopamine. And so he started giving them drugs to replace the dopamine and found that they actually started behaving and they actually awoke and started behaving normally. If you haven't seen it, you should go see this movie. It's one of the best neuroscience movies ever. And then the red nucleus, which is the origin of the rubrospinal tract, is also responsible for movement. Here you have the inferior colliculus, that bumped, which is involved in the auditory pathway, and has a nice tonotopic map, meaning you stimulate different parts of the inferior colliculus, and as you move across, the sound starts going whoa, 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 if you could do that easily.